Today let's discuss about 2017 LL passing question from the lesson Remainder Theorem. Before we do that, let's do a small recap of the lesson. First we should learn what's a degree. Degree means normally the highest power of the variable. Highest power of the variable. Okay, so if you take degree 0, that means x to the power 0, you know index 0 of any base is equal to 1, so x to the power 0 is equal to 1, so x to the power 0 is also equal to 1, so we can write this either as a or as k. Okay, when the degree is 1, that means x to the power 1, which will be ax to the power 1 plus b x to the power 0. I told earlier that x to the power 0 is 1, so it will be b just b only, as b x to the power 0 is equal to 1, so it will be just b only. And degree 2, x squared, a x squared plus bx plus c, 2 1 0. When the degree is 3, x to the power cube, which will be a x cube plus bx squared plus cx plus b, 3 2 1 0. Okay, and then the degree is 4, which will be x to the power 4, a x to the power 4, b x to the power 3, c x to the power 2, d x to the power 1 plus e x to the power 0, that's e. 4 3 2 1 0. Okay, so that's what a degree is. Now let's move on to factor theorem. Now normally factor theorem means simple division. Factor theorem means simple division. If we divide 9 by 4, you know there are 2 4s in 9, so 2 into 4 it will be 8, 9 minus 8, answer will be 1. So there's a remainder of. Likewise, we have divide polynomials or expressions, algebraic expressions in this same manner. Let's divide 2x cubed plus 3x squared plus 4x minus 4 by x squared plus 3x plus 1. Okay, we compare this term, first term of this by first term of this. Normally we call this the dividend. This is known as the divisor. Whatever value we get here, we call it the quotient. Okay, and if there's a remainder, it will be the remainder. Okay, first we should divide the first term of the dividend by the first term of the divisor. That will be 2x cubed divided by x squared. Here, same ways, according to Indices law, powers is subtracted. 3 minus 2 answer will be 1, so it will be 2x. So earlier when we divided 9 by 4, we got the answer 2, and we multiplied 2 by 4 and we got 8, and 9 minus 8 answer was 1. Likewise, when we multiplied 2 by all of these 3 terms, 2x into x squared, 2x cubed, 2x into 3x, 6x squared, 2x into 1, it will be 2x. So 2x cubed plus 6x squared plus 2x. So 2x squared cubed minus 2x cubed, answer will be 0. 3x squared minus 6x squared Answer will be minus 3x squared, 4x squared minus 2x, answer will be plus 2x, and here we bring this minus 4 here. Okay, and minus 3x squared plus 2x minus 4 should again be divided by the divisor. First term of this should be divided by first term of this. So these are common terms, it get cancelled. So here we get minus 3. Again, like we earlier, we should multiply minus 3 by all these 3 values. Minus 3 into x squared, minus 3x squared, minus 3 into plus 3x, minus 9x, minus 3 into plus 1, minus 9. Here minus 3x squared minus 3x squared, it will be plus, so it will be cancelled, and div inverse is there, and plus 2x minus 9x, and div inverse is there, so it will be 11x. Here minus 4. Here it should be not minus 9, should be minus 3. Minus 3 into 1, it should be minus 3, not minus 9. Minus 3 into x squared, minus 3x squared, minus 3 into 3x, minus 9 is minus 3 into plus 1 will be minus 3. So minus 4 minus 3. So here minus 4 plus 3, answer will be minus 1. Here we can't go further than this, because here the degree is 1, x to the power 1, x to the power 0. Highest power of the variable is x to the power 1, so degree is 1. Here the degree is 2. So here degree is higher than the degree here. So we can't go further than this. This is the furthest we can come. Normally degree of this side should be either higher than the degree of the divisor or should be equal to the degree of the divisor. It's 3 and 2, it's 2 and 2. It should be either higher or it should be equal. It's lower than the degree of the divisor, so we can't divide. So here it will be a remainder of 11x minus 1. Here it will be the remainder. Here it will be the remainder. Okay? And here we have the divisor, and as I told earlier, this is the quotient. This is the dividend. Okay. You can observe something here, that is degree of the remainder is 1 less than degree of the divisor. Degree of the divisor is 2, degree of the remainder is 1. Here degree of the remainder is degree of the remainder is 1 less than degree of the divisor. Here and also you can see degree is 2, degree is 1, degree of the dividend is 3. You can also notice that degree of the dividend, which is 3, is equal to degree of the divisor plus degree of the quotient. Highest power of the divisor is x squared, so degree means highest power of the variable. So degree is 2, highest power of the quotient is x to the power 1. So degree is 1, 2 plus 1 is equal to 3. So here degree is 3. So you can see quotient degree plus degree of the divisor is equal to the degree of the dividend. So you should remember those two things. We will be using those two things in the remainder theorem. Now let's move to the remainder theorem. This is the main part of the lesson. Remainder theorem. Earlier, when we divided 9 by 4, we got 2 and 2, 8, 1. So, 9 is equal to 4 into 2 plus 1. Likewise, we can derive a formula for remainder theorem as well, which is dividend is equal to, this is divisor, 4 is the divisor, into quotient plus remainder. 9 into 4 plus 9 is equal to 4 into plus 1. So here this is dividend equal to divisor into quotient plus 1. You can derive formula like this should be the theorem. It is equal to dividend, it is 9 is equal to divisor is 4 into quotient plus remainder. Okay. Dividend is equal to divisor into quotient plus remainder. Dividend is equal to divisor into quotient plus remainder. That's the main theorem you should memorize. And the other theorem is that degree of the dividend is equal to degree of the divisor plus, it should be plus, okay, plus degree of the quotient. Degree of the dividend should be equal to degree of the divisor plus degree of the quotient. And also here 9 is equal to 4 into 2 plus 1. Here divisor into quotient 8 plus 1 9. So dividend is equal to divisor into quotient plus remainder. Okay. I mentioned it earlier as well. Degree of the remainder is 1 less than degree of the divisor. Degree of the remainder is always 1 less than degree of the divisor. Degree of the remainder is always 1 less than degree of the divisor. Now let's move on to the 2017 error question, as this is remaining here. We discussed it. Let's move to the 2017 error question. So now let's do the same sum we did using factor theorem and remainder theorem to check if we get the same answers. So this is 2x cubed plus 3x squared plus 4x minus 4. This is a dividend. X squared plus 3x plus 1. This is a divisor into quotient plus remainder. We don't know the quotient, we don't know the remainder. But we know degree of the remainder is 1 less than the degree of the divisor. Degree of the divisor is 2. So degree of the remainder will be 1. So we can represent degree 1 like cx plus b. Okay. So quotient, degree of the quotient should be 1 by, we learned that degree of the dividend is equal to degree of the divisor plus degree of the quotient. So it should be also 1. We can use cx plus d, we will use ax plus b. So this is degree 1 as a, this is degree 1 as 1, 0, 1, 0. Highest variable is x and highest power variable is 1. Okay. First we should multiply these two, ax squared plus 3x plus 1 into ax plus b. X squared into ax will be ax cubed, x squared into b, that will be bx squared, 3x into ax, that will be 3ax squared, 3x into b, that will be 3bx, 1 into ax, it will be ax, 1 into b, that 1 into b, that will be b, and here we have cx plus d. And we should equalize coefficient of powers. First we should take x cubed. Here the power is coefficient is 3 and the coefficient is 8, and here the power is 3 and the coefficient is 2. So a will be equal to 2. And when you take x squared, here we have b and 3a. b plus 3a is equal to x squared. So here also x squared we had at 3. So b plus 3a is equal to 3. 3a is equal to 3 into 2 is 6. we can bring 6 to the other side, that will be minus 6. So b is equal to 3 minus 6, b is equal to minus 3. B is equal to minus 3. And x to power 1 we have, x to power 1 we have 3bx, 3b plus a and plus c. That's x to power 1. Here we have x to the power 1 as 4x. So 3b plus a plus c should be equal to 4. 3b is minus 9. A is 2 plus c. Minus 9 plus 7 plus 2 is minus 7. Plus c is 4. We bring it minus 9 to the other side, it will be plus. C will be equal to 8. Okay, after that, one left is constant, all power 0. Those are d and b. Here we have d and b, and here the constant is minus 4. Minus 4 should be equal to b plus d. Here b we know minus 3. Minus 3 plus d is equal to minus 4. Bring minus 3 to the other side, it will be plus 3. Minus 4 plus 3, d will be equal to minus 1. Here we can write quotient and remainder. Quotient is ax plus b. So a is 2, 2x. B is minus 3, 2x minus 3, and remainder is cx plus d. So c is 11x. C is 11, so it will be 11x, and d is minus 1. So remainder is 11x minus 1, quotient is 2x minus 3. So you can check these two are the same answers we got when we solve the same sum using factor theorem. They are asking, let gx be a polynomial that gx is equal to x cubed plus 2x squared, x cubed plus px squared plus qx plus 1. X cubed plus px squared plus qx plus 1. P and q both are integers. When gx is divided by x minus 1 and x plus 2. So you can say this is the divisor. This is the dividend. So dividend is equal to divisor into quotient. We don't know the quotient, so that quotient g, quotient x, here it's x, so it will be quotient x plus the remainder they are saying is 3x plus 2. Remainder they are saying 3x plus 2. Okay. So dividend is equal to divisor into quotient plus remainder. Okay. So divisor is x minus 1, x plus 2, quotient x, we don't know quotient, and the remainder. So quotient is qx. It's gx, it will be means quotient x, qx. They are asking to show that remainder in gx is divided by x minus 1 into quotient x is equal to 5. So r should be equal to 5. Here you can see x minus 1 is here. First we should equalize this to 0. X minus 1 is equal to 0, x equals to plus 1. Here, so we can substitute instead of x equals 1, we should substitute this to the this polynomial or this expression. We can call it number 1. So x equals 1, substitute x equals 1 to the first. Okay. So it will be g, here is x, we are substituting 1 instead of x, so it will be 1 is equal to x minus 1. So here x is 1, so 1 minus 1 is 0, 0 into x plus is 0, 0 into quotient x is 0 into 3x, x is 1, 3 into 1 plus 2, so 3 into 1 is 3 plus 2 is 5. So we got the remainder as 5. After substituting x equals 1, which we got from equalizing x minus 1 is 0. This after substituting x equals 1 to the first this polynomial 1, we got the remainder as 5. So we can write, therefore the remainder when gx is divided by x minus 1 is equal to 5. So this is the 2017. This is the 2017 error. First is equal to 5. So this is the first. So this is the first part of the 2017 error question. So you can, at the end of the question, we have to get right. Remainder is, therefore the remainder when gx is divided by x minus 1 is equal to 5, which we got by equalizing x minus 1 is 0, x equals 1. We substitute x equals 1 instead of x to the first equation of this polynomial, and here we got 1 minus 1 is 0, 0 into 0, 0 into quotient is 0, plus 3 into 1 is 3, plus 2, that's 5. Okay. Now let's move to the second part of the question. In there, they are asking when find the remainder when they are asking to find the remainder when this polynomial is divided by x plus 2 and the remainder should be equal to minus 4. Show that the remainder when gx is divided by x plus 2 is minus 4. Again, as we did earlier, we should equalize this to 0. X plus 2 is equal to 0, x equals minus 2. So we should substitute x equals minus 2, x equals minus 2 to the first one, the first equation of this polynomial. So we get g minus 2 is equal to minus 2 plus 2 0, 0 into x minus 1 is 0, 0 into quotient is 0, 3 into minus 2 plus 2, 3 into minus 2 is minus 6, plus 2 will be minus 4. So they are asking us to get remainder should be equal to minus 4. Here we got minus 4. Now we write a statement. Therefore, when gx is divided by x plus 2, remainder is equal to minus 4. So this is the second part of 2017 error question. So now let's move on to the next part. In there, okay, now let's move on to the next part. In there, they are asking. Okay, now let's move to the next part. In there, they are asking find the values of p and q and show that x plus 1 is a factor of gx. So we will find the values p and q. So now here we have to use the theorems. We learn it remainder theorem. Okay. What are the theorems? Dividend should be equal to divisor into quotient plus remainder. Degree of the dividend is equal to degree of the divisor plus degree of the quotient, and degree of the remainder is 1 less than degree of the divisor. So first we will find the degree of the divisor. At first you may think it's degree 1. No, it's not degree 1. We have to first multiply these two. This is a binomial expression, so it should be degree 2. So x into x will be x squared, x in plus 2, that will be plus 2x, minus in minus 1 into x, it will be minus x, minus 1 into plus 2, that will be minus 2, plus 2x minus x, it will be plus x. So it will be x squared plus x minus 2. X squared plus x minus 2. That is the divisor into quotient x, we know the quotient, plus remainder is 3x plus 2. We know the dividend. Here degree of the dividend is 3, degree of the divisor is 2. So then the second theorem on the remaining theorem, degree of the dividend should be equal to degree of the divisor plus degree of the quotient. So we can easily get that degree of the quotient is 1. 1 plus 2 is 3. So if the degree is 1, we learn how to represent degree 1 by how ax plus b plus the remainder is 3x plus 2. Plus remainder is 3x plus b. 3x plus 2. Okay. So divisor, degree of the divisor is 2 and degree of the quotient is 1. 2 plus 1 is equal to degree of 3, which is the degree of the dividend, and this is the remainder. Okay, so which is 1 degree less than the degree of the divisor. Degree of the divisor is 2, degree of the remainder is 1. So here degree 1 we represent using ax plus b. Now we have to multiply these two expressions and quotient the divisor, and we should equalize coefficient of powers of this side of the equation to this side of the equation. Like here it's dividend, here it's quotient, and divisor and remainder. Here it's dividend, it's quotient, divisor and remainder. So we should equalize coefficient of powers of this side to the coefficient of powers of this side. So let's multiply x squared into ax, that will be ax cubed, x squared into b, that will be x squared, x into ax, that will be ax squared, x into b, that will be bx, minus 2 into ax, minus 2ax, minus 2 into b, minus 2b, and then remainder also we should add, plus 3x plus 2. Okay. Okay, so it will be x cube is here, so only x cube available here is this one, so it will be a x cube, and for x squared, b and a, what is there, bx squared is there, and ax squared is there. B plus a squared, and for x, for this x degree 1, we have b minus 2a and 3x, b minus 2a and 3x, and for the constant we have minus 2b and 2, minus 2b and 2. Now we should equalize the coefficient of powers of this side of the equation, the coefficient of powers of this side of the equation. Now let's equalize. Here coefficient of equalizing coefficients of powers. Equalizing coefficient of powers. Here a and here a x cube is here and x cube is also here. So coefficient of x cube is 1. So a is equal to 1. And x squared, coefficient of x squared is p. So b plus a is equal to p. So a is 1. So b plus 1, a is 1. So we can write b plus 1 is equal to p. And a coefficient of x cube, q is equal to b minus 2a plus 3. b minus 2a plus 3 is equal to q. We know a is 1. We know a is 1. Minus 2 into 1 is equal to minus 2. Minus plus 3. Minus 2 plus 3 is plus 1. So we can say b plus 1 is equal to q as well. b plus 1 is equal to q as well. And at last, constant we have minus 2b plus 2 is equal to, here the constant is minus 1. Minus 2b plus 2, here the constant is plus 1. So we can bring plus 2 the other side. Minus 2b equals to 1 minus 2. Yeah, you can see that. Okay, now the only part left is a constant. Constant here we have minus 2b plus 2 here we have. So minus 2b plus 2. Here the constant is plus 1, should be equal to 1. We can bring minus plus 2 the other side. That will be minus 2. 1 minus 2 will be minus 1. So minus 2b will be equal to minus 1, and we can divide both sides by minus 2. So b will be equal to half. Okay, we can divide both sides by b is 2b is equal to now the only part left is a constant. Minus 2b plus 2, here the constant is available is 1. So it should be equal to minus 2b plus 2 should be equal to 1. We can bring plus 2 the other side as minus 2. Minus 2b equal to plus 2 minus 2 will be plus 1 minus 2 will be minus 1. So we have both of them minus 2. B should be equal to half. Okay, so now we know A is equal to 1, B is equal to half. We can find P and Q. B is half. B plus 1 is P. B plus 1 is, can I name this as 1 and this is as okay. Here we can say B plus 1 is P, B plus 1 is Q, and we know A is 1 and B is equal to half. So we can name this is 2 as we named 1 earlier, and this is 3. So P, substitute B equal half to 2, so it will be, we can get P then. So B plus 1 is equal to P, half plus 1 is equal to P. So we can get a common denominator, we should multiply this by 2, so it will be 2 on the bottom, denominator is 2, 1 plus 2 is this, so it will be P, so it will be 1 plus 2 over 2 is equal to P, so it will be 3 over 2, P is equal to 3 over 2. So we can get P is equal to 3 over 2. By default, we know these both values are same. So we know P and Q both are same. How? Both are B plus 1 is equal to P, P plus 1 is Q. So we can write, so by default we know Q is equal to 3 over 2, but we should write Q substitute B is equal to half to 3. So B plus 1 is equal to Q. So half plus 1 is equal to Q. So B 2 1 plus 2 is equal to Q. So 3 over 2 will be Q. So we can get Q is equal to 3 over 2. It should be equal to 3 over 2. Okay. So we got A equals 1, B equals half, P equals 3 over 2, and Q equals 3 over 2. After they ask you to show that x plus 1 is a factor of this gx or this polynomial. X plus 1 is a factor of this polynomial. So when I can say 3 is a factor of 9. Why? 9 divided by 3 is 3, 3 into 3 is 9. So there will be no remainder. Remainder is 0. If the remainder is 0, that means it's a factor. If it's mentioned a factor, automatically then it will be the remainder will be 0. If the remainder is 0, it will be a factor. If it's mentioned a factor, automatically the remainder should be equal to 0. Okay. So here when we substitute x plus 1 to this polynomial, we should get 0. Gx equals gx is this one, so it will be equal to x plus 1 into quotient x plus remainder. There will be no remainder because they have mentioned that they show that x plus 1 is a factor. So if it's a factor, there will be no remainder. That I should write. So r. If the r is 0, then we can show that with this gx, x cubed plus 3 over 2, x squared plus 3 over 2, x plus 1 is a factor. So this should be 0. R should be 0. Okay, we have to show that. Okay, so equals to 0, x plus 1 is equal to 0, x equals minus 1. Right, g minus 1 is equal to, substitute this equation, minus 1 cube plus 3 over 2 minus 1 squared plus 3 over 2 into minus 1 plus 1. Minus 1 cube minus, if the index is odd number to the to a negative base. If the index is odd number to a negative base, always answer will be negative. Here 1 to the power 3 is 1, so it will be minus 1. Here the index is even to a negative base, so it will be plus value, so it will be plus 2, and here automatically it will be minus 1, minus it will be minus 3 over 2 plus 1. Here it will get cancelled, plus 3 over 2 minus 3 over 2 and minus 1 plus 1 get cancelled, so it will be 0. And here also minus 1 plus 1 0, 0 in here, and so r will be equal to 0. We can say, yeah, so r will be equal to 0. Let's say since there is no remainder and x plus 1 plus 1 is a factor of gx. I hope you understood what's a degree. Degree is normally the highest power of the variable, and what's remainder theorem, what's factor theorem, and how we solve the 2017 error question. Okay, that will be there. Thank you so much for watching.